Okay, we are going to start. Please go to the page 98. 98. The topic is solve multi-step equations. Example 1. Use the distributive property to solve a multi-step equation. Example 1. A math teacher recorded the distance he rode his bike last week. He challenged his class to find the number of miles he rode on Thursday. How far did he ride on Thursday? Okay, you have the distance represented. You represent the distance, like in the part at the right, you have from Monday, Tuesday, and Wednesday. Monday, Tuesday, and Wednesday is equal 4x plus 3. On Thursday, I'm going to find the value. I don't have the value, so the value for the x is what I need to find the x. In Friday we have x plus 7. And on Saturday I have x plus 7, the same distance of the Friday. The total number of miles he rode on Monday through Wednesday is the same as the total numbers of miles he rode on Thursday through Saturday. Okay, if we draw a bar diagram to represent the situation, you can see it on the part below, we can use this diagram to write the equation. I have 4 times x plus 3. Later you have x plus 7, and again x plus 7. So you copy this to form the equation. You have 4x plus 3. This is from Monday through Wednesday. This is equal x. This is the Thursday I need to find, plus 2 times x plus 7. Remember, we have to write 2 times because I have the same distance in Friday and in Saturday. So I have 2 times x plus 7. And the quantity appears twice, so you can write it simplified. In this case, you are only going to multiply by 2. Now we only have to solve the equation. This is the same kind of exercise we were working in the last class. We isolate the variable and we need to find the value for the variable they are asking me. Okay, so distribute the 2 to the terms inside the parentheses. This is when you are solving 2 times x plus 7. So we need to find it. I'm going to solve it with you on the board. Maybe we can finish today until the example 3, and tomorrow we can solve a class work. So start, and if you have any question, I'm going to give you some time later to find this. I don't know if I'm going to solve all the steps like on the book, but I'm going to try. And if at one point it's different, it appears to be different because at the end it's going to be the same. So start. You have 4x plus 3. 4x plus 3 equal x plus x 2 times x plus 7. Okay, I think that you can see it very well. I only need to solve this. Remember, I move the variables for one side and I keep the numbers in the other side. The first step I need to solve is this one. The 2 is affecting x and the 2 is affecting 7. So I'm going to multiply the 2 by both numbers. I copy the same for x plus 3 equal x plus 2 times x is 2x plus, this is the sign, 2 times 7. 2 times 7 is 14. I think it's okay until here. Now, remember, I don't want variables in this side of the equation, so I'm going to move the variables into the to the left side. And the numbers, I'm going to move it to the other side. I want to move the numbers to the right. So if I write this, I have 4x minus x minus 2x. I write the minus because you have positive in here, positive and positive. So when I pass it to the other side, I change the sign, minus and minus. This is equal 14, and the 3 that is in addition, I'm going to pass it to the other side to subtract. 14 minus 3. If the 3 is subtracted in here, I pass it to the other side, addition, in addition. So in this case, it's addition, I pass it to subtraction. Okay, I only need to subtract in this. 4x minus x is 3x, right? 3x minus 2x. And if I subtract 3x minus 2x, I obtain only 1x. I'm only subtracting the numbers. 4 minus 1 is 3, minus 2 is 1. And copy the variable, 1x. But when you have 1, you don't need to write it. If you only copy the variable like this, is 1x. You don't have to write the 1. Equal 14 minus 3. 14 minus 3 is equal 11. You can see at the book, I'm going to explain you. Now, many things that in the book, they write more steps, but solving your equation is only this. And you can see that the answer at the same is the answer at the end is the same. We can check the answer. We replace the number we obtained, we replace the 11 into the original equation. For example, in this case, 4 times 11. Instead of the x, I write 11 plus 3 equal 11 plus 2 times 11, that is going to be 22 plus 7. You only solve this and it has to be the same result. 4 times 11, it's 44 plus 3 is 47. And in this case, 22, 20. Okay, I'm going to see if they write the number in here. Yes. Oh, sorry. It's only the parentheses. It's until here. Okay, that's the reason. Okay. 2 times 11 is 22 plus 14 plus 11 equal 47 too. This part of the equation is equal to the other part of the equation. So you don't even know this part. I'm going to erase it because you have it on the book. I was only showing you that they only replace the value. Instead of x, you write 11. When you find if the answer is correct or not, okay? Only for that. We saw this exercise in only 4 steps, and three steps. 1, 2, 3. Multiply the number that is affecting the parentheses. Later, move the variables to one side and keep the numbers on the other side. And we do it faster than in the book. They do the exercise. Now I'm going to read the exercise with you to see if there are any additional steps or something. For example, the first line, they solve the multiplication too. But okay, the only different part is that they write everything. We solve the multiplication or the division in the first step. Later, they move the variables to one side, like we did in the second, in the third line. Okay, you can see it in there. On the third line, we only move the variables to one side and the numbers to the other side. And the last step is to find the value for the x. Yes, so we obtain that the variable x is equal 11. So on Thursday, if we give the answer, if on Thursday, the math teacher recorded the distance and he rode his bike 11 what is in kilometers or miles? I don't know. Miles, it's 11 miles, okay? He rode 11 miles. The part that says try it is the same. You solve the equation. We are going to solve it if we have time at the end, but for now, go to the example 2. And they are the same kind of exercise, but I want to explain you the example 2 because in this one we have negative numbers. That's why I want to explain you the example 2. We have two exercises, the A and B. So solve each equation. On the example A, I have negative x minus 2 equal negative 25. I'm going to solve this with you. Okay, I have negative 5. Negative 5 is multiplying x minus 2. And this is equal negative 25. Negative 25. Okay. How can we solve this? The first step I need to do is to multiply the number that is affecting my parentheses. And if I solve this part, I have negative 5 times x is negative 5x. Negative 5 times negative 2 is going to be positive 10. Positive because you have negative in here and negative in here. This is equal negative 25. Can you see it? Only one step, we multiply. Now, I need to write my variables in one side, and I'm going to keep the numbers on the other side. So the 10, in this case, is in addition. I'm going to pass it to the other side to subtract. Minus 5x equal negative 25 minus 10. Negative 5x equal negative 35. Remember, we add the negative numbers. Negative 25 plus negative 10, it's negative 35. Remember, both are negatives, so it's a addition. We add the numbers and at the end we write the negative. I don't want any number multiplying my variable like in here. Remember what we have to do when we have one number multiplying my variable? I pass it to the other side to divide. So I have that x is equal negative 35 over negative 5. This is the line of the division. It's only that I don't have the space enough to write it over. Negative and negative, the answer at the end is going to be positive. Negative, negative is going to eliminate. And one number that multiplied 5 times is equal to 35. It's 7, right? So the answer is going to be x equal 7. Or you only divide, okay? We're only dividing 35 by 5, and it's 7. X equal 7. Is the same result we have on the book? Yes. They write in this way. Okay, they multiply in both sides. If, for example, I have negative 5x equal, I don't know what now. They multiply in both sides to eliminate. They divide negative 5 in here, and they do the same in the other side. They pass to multiply and divide by 5 again. They write all the steps, but you don't need to write everything if you are understanding what are you doing. I have the 5 multiplying, I pass it to divide. If the 5 were dividing, I would pass it to multiply to the other side. So it's only to remember about the inverse operations, and it's only to remember that I want to keep my variable alone. I want to isolate my variable because I want to know the value of this variable. I cannot have my variable with another number. So, okay, we can solve the example B. Okay. May I erase this part? Yes? Okay. We are going to solve the exercise B. You already have it on the book, but I want to explain you each step and to remind you about the inverse operations. The exercise B is 3 minus x minus 3. This is equal 25. In this case, it's positive. Well, the 25 is positive. Okay. 3 minus. I'm not going to multiply the 3 because it's subtracting, it's not multiplying. But what number is multiplying the parentheses? It's like you have an imaginary 1 in here. With the negative, it's like you have negative 1 multiplying this. You don't write the 1, but the minus is not alone. The minus is with the 1 multiplying the parentheses. So I'm going to change the sign of each one of the numbers inside the parentheses. It's like I multiply by negative 1. You multiply by negative 1 the x and by negative 1 the 3. So I have 3 minus x because negative 1 times x is minus x minus times minus is going to be positive 3, and this is equal 25. Remember, we multiply by each term of the parentheses. We multiply by each term. Okay. This negative is outside of the parentheses. So this negative is affecting all the terms that are inside my parentheses, in this case, the x and the 3. Don't remember about that, okay? That's the reason why I try to focus on this part. The next step is what? To keep the variable on one side and the numbers without the variable in the other side. So I have negative x, you don't change the sign. The x is going to keep in this side of the equation, so you are not going to change the sign. The x is already in here, so you keep it in here with the negative. You are going to change the signs of the number you pass to the other side of the equal, to the other side of the equation. 25, you already have it in here, the 25, and you subtract the 3 because the 3 was positive. Only that I don't write the positive. I don't write the positive, so I'm going to the other side to subtract the 3. And now I have this other 3. This is in addition. I'm going to pass it to the other side to subtract again. Minus 3. And how I'm going to find the result? Negative x equal 25 minus 3 is 22. 22 minus 3 is 19. But I don't want any number multiplying my variable. And remember that I have negative in here. It's like you have one negative. Negative 1 multiplying my x. So if I pass this negative 1 to divide in here with the negative number, with the negative, at the end, if you pass the negative to the other side, you have x equal negative 18. Remember, my variable is positive. My variable has to be positive. So the negative you have, you pass it to the number you have on the other side. So x is negative 19. You can see it on the book. They did this. You have x equal 19 over negative 1. It's what I have in here. If you divide 19 by negative 1, you obtain the negative 19. Because in here it's like you are multiplying by negative 1. Remember that when you have the negative, it's like you are multiplying by negative 1. So I'm going to erase it so you don't get confused. But this is what we do. That's the reason why the negative passed from here to the number. Okay. In this point, before we solve the example 3, I'm going to give you some time if you want to ask something about the class. Rafael, any question? I'm going to ask randomly. I'm going to only see if you're paying attention, every one of you, to check the cameras. If you are not sleeping or something like that. Victor, Gabriel, Jose Valle, Angel, Mia, what's happened? What happens with your camera? Sue, Gabriel? Okay. When you deactivate your camera, I assume that you are on the couch watching TV or something like that. Okay. If we have time, if you want, we can go to the example 3. The example 3 is the same. We only have one difference in here, and the difference is that I have fractions. That's the only difference, but I'm going to solve it in the same way I've solved the first one. I'm only going to write this because I am not sure how much time we have. I think 10:25 finish the class, right? Okay. I'm only going to show you. I take 1 minute and I finish. Only to show you how are you going to solve the exercise. You have, for example, in the first part, 1/4 x plus 3. Yes, we are going to do the same. You multiply the fraction by each term. We are going to solve it tomorrow that we have more time, but today I'm only going to show you what are we going to do. Multiply the fraction by the first term and the fraction by the other. 1/4 x and multiply 1/4 by 3. So you have 3 times 1 is 3 and the 4 times 1 is 4. And the same with the other side of the equation. You only multiply to obtain the equivalent expression. Guys, if you don't have any question, we can finish this exercise tomorrow, and tomorrow we solve the class from pages 100, 101, and 102. I think these kind of exercises are easier than the exercise we were solving before. So, see you guys, take care, and have a nice day.